Hello sir, I am Rochit Roy Chaudhary and now I'm going to present our systems engineering experiential learning project which is on aircraft aircraft system designs. So I am Rochit Roy Chaudhary and my teammates are Tanish Gupta, Shivan Singh and Utkarsh Patel. So now I'm going to start. Yes. So, first of all, what is aircraft design system? So, it is a multifaceted process integrating various engineering disciplines so as to create very uh, efficient and reliable aircraft. So, it involves thorough understanding of aerodynamics, material science, etc. So, how come is it a system? Why is it forming a system? So, as we all know, like I've told, it is a interdisciplinary approach. It follows an interdisciplinary approach, and the disciplines it encounters are like aerodynamics, avionics, propulsion systems, material science, hardware designing, etc. It also manages life cycle management, which covers the entire life cycle of the aircraft from the initial concept designing to including the phases like requirement analysis, conceptual designing, preliminary designs, etc. And then comes the integration and optimization part, which focuses on integrating and optimizing the various subsystems which have been conceptualized and designed, ensuring the compatibility with the current systems. So yes, now we have divided the whole system into multiple phases. So the phase one would be the requirement analysis or the need analysis of the aircraft. So we could start it by taking an example of Boeing 747-8s, which have been recently decommissioned by Boeing. So from this example we can take out what are the need analysis and how come these needs are being fulfilled and being taken into the concept designing phase. So 747 which have been decommissioned was struggling with fuel efficiency as it had four engines. It dealt with four engines which were having much higher operating cost as well as were taking in too much fuel as compared to the twin engines in 777 and 787 Dreamliners. And it also led to more maintenance and the crew and overall crew led to much higher operating costs as the newer versions of the Boeing aircraft. So, and it was massive in size. So this led to a problem, and which was very massive, which was the filling of the seat, which was very less in busy routes. So it was financially very crucial for for Boeing company. Hence, it was decommissioned recently in 2023, and it was started as in commissioned in 1970s. So from this, we can take out the needs of the newer designs of the aircrafts, which would be uh, like cost and budget constraints. Firstly, we will talk about. So we'll have to consider all the research, designing and testing expenses, which must be very nominal, which will be very nominal, and the production and operating and life cycle costs must also be as less as possible. Then comes the risk management, all the technical risks, then scheduling risks, can be like timeline constraints, and then the financial risk, etc., has also to be taken care of. Then comes the other needs such as integration with the existing systems, such as integrating the new radar systems with the air traffic control management systems which are being used recently, which are being designed in the recent times, and how in the most efficient way the system can be integrated to the newer systems. And then comes the stakeholders identification, which is also very crucial step in the requirement analysis phase. So the stakeholders in aircraft designing would be the firstly the companies itself, like Boeing, Airbus, etc. Then comes the regulatory bodies such as DGCA, FAA, etc. And in the secondary stakeholders, we can identify crews, then the ground support staff, suppliers, caterers, etc. So yes, then comes the consultation phase, in which we engage with the airlines to understand the specific routes they will be taking and the requirement they will be having, fuel efficiency goals, etc. Then collaborate with the regulatory bodies to ensure compliance, such as with the DGCA. And then comes to gather the feedback from the end users, which are the customers, about about the like comfort features and the flight entertainment systems, etc. And then we have to perform thorough market research and feasibility studies. We'll have to conduct a market research to assess the demand for new aircraft models, analyze the travel trends in the modern times, identify the emerging markets like new tourist destinations, etc., and then analyze the competitive landscape to identify unique selling points, etc. Yes. So what would be the outcome of this analysis, requirement analysis phase? So we'll have a detailed and structured document, which will be outlining all the technical and operational requirements of the flight system, aircraft system. It will be serving as a foundational reference throughout the subsequent design phases, and will be also ensuring all the stakeholders needed who are considered and integrated into the design process. Then comes the conceptual designing phase. So we'll have to brainstorm all the ideas we could from a multidisciplinary team to generate a wide range of design ideas. And the factors to be considered would be, first of all, aerodynamic efficiency, to analyze the different shapes and configurations so as to save as much fuel as possible. Then comes the safety issues, to ensure the designs meet stringent safety standards and all the structural integrity and emergency handling. Then cost effectiveness, which is also a very important factor, evaluating the cost implications. Then manufacturability, which is also important, as the whole assembly line would have to be designed as per the manufacturability of the new aircraft systems. Then comes the sustainability. We'll have to also consider the environmental impact of the aircraft which will be flying. Yes. In the second part of the conceptual design phase, we'll have to perform trade-off studies. So it will consist of performance metrics, like we'll be using multiple simulation tools to simulate all and every design aspects of the aircraft, in terms of the speed, range, aerodynamics, fuel capacity, efficiency, etc. It will be about then we'll have to perform a cost analysis, to perform a detailed cost analysis considering initial production cost, life cycle maintenance costs, etc. Then comes the risk assessment, as I told, like technical risk, schedule risk, financial risk, etc. Then we'll have a decision matrix to make, which will to systematically compare the trade-offs of each design option based on the established criteria of the stakeholders' priorities. And then comes the preliminary reviews. So we'll have to perform feasibility assessment, to conduct a preliminary feasibility study with whether the aircraft design is feasible or not, and to determine the practicality of each design concept so as to select the best one. And then comes the performance simulations. So we'll be using advanced simulation softwares to model the aerodynamic, structural integrity, etc. of the plane. Then again perform the risk analysis, and then we'll have to take the stakeholders' feedback. So based on all the documents and the simulation which we have created, we'll have to present it to the stakeholders, and based on their reviews and feedback, then we'll have to select the best concept.
Hello everyone, this is Tanish Gupta and I'm from Telecom Department. Today I'll be walking you through two important phases of aircraft design, that is the preliminary design and the detailed design. So let's dive right in. Okay, so the in preliminary design, it is a very crucial phase because it is the place where the chosen concept from the conceptual design phase is refined into a more detailed blueprint. So let's talk about the few points in preliminary design. The first being the refinement of concept. This means we hone in the aircraft overall architecture, setting the dimensions, weight, and shape precisely. Now talk about the detailed specifications of this design. Okay, there are mainly four specifications. First being the aircraft structure, then the propulsion system, avionics, and the interior layout. Talking about the airframe structure, engineers define the structure of the aircraft including the materials used, load-bearing components, and the overall structural integrity. The material commonly used here is the aluminum alloy. Now, propulsion system. The specifications for the engine used in the aircraft design or other propulsion mechanisms are developed in this system, considering the thrust requirements, fuel efficiency, and integration with the airframe. Now, talking about the avionics. Electronic systems used for communication, navigation, and flight control are specified. This just means that in an aircraft design, there are many factors which control the movement of aircraft. That are the communication, the way we want to navigate, how the flight will be controlled. So all these specifications will be taken care of by the avionics section. This also includes the radar systems, GPS, and other important things. Now, interior layout. The layout of the cabin, the including the seating, cargo spacing, the interior components are all taken care by this specification. This generally means when you enter a aircraft, there are multiple things that you see. First being the cabin of the pilot, then there being the space where we sit, and also the cargo space where the luggage is being stored. So all these specifications are taken care by these uh, interior layout. Talking about the analysis and simulation, there are again three type of such analysis: aerodynamic analysis, structural integrity assessment, and computational simulation. So, talking about the aerodynamic analysis, CFD and wind tunnel testing are mainly used to analyze and optimize the aircraft aerodynamic performance. Now, CFD stands for computational fluid dynamics, and wind tunnel testing is self-explanatory. Then comes the structural integrity assessment. Stress and fatigue analysis are used here. Then comes the computational simulation. Simulations validate design assumptions, optimizing performance metrics like lift to drag ratio, range, and payload capacity. The last thing about the preliminary design phase is the output. Like what can we expect from this phase? That is preliminary design document, system architecture diagram, and the feasibility analysis report. In the design document, these documents outline the refined design details and serve as the basis for further development. This just means that whatever we have developed, whatever we have researched about, we just put it into a document. The system architecture diagram shows what we have learned and how we are going to implement it. And the feasibility analysis report assesses the feasibility of the design that we have already uh, planned about and how feasible it will be for us to develop. So let us go on to the next phase, that is the detailed design phase. This phase involves creating comprehensive engineering drawings and specifications for every component and subsystem of the aircraft. This phase ensures all aspects are meticulously planned for the production. In last phase, we just planned things. This phase ensures that we are preparing the plan in a detailed and specified manner. So, what does engineering drawings and specifications include? Mechanical system, electrical system, software system. In mechanical system, aircraft mechanical components such as landing gear, control surfaces, and actuators will be recorded. In electrical systems, wiring diagrams, power distribution systems, and integration of avionics and other electrical systems will be taken care of. In software system, detailed specification of the controlled avionics, flight management system, and other onboard systems will be taken care. Now, moving on to the manufacturing consideration, there are three types of manufacturing consideration that needs to be taken care: material selection, manufacturing processes, and assembly procedure. In material selection, choosing appropriate materials for each component based on strength, weight, and other properties is important. In manufacturing processes, defining the processes based on their machining, welding, and composites manufacturing capability is really important. And then come the assembly procedure. This just means the all the materials that we have manufactured, we need to assemble it properly in a procedural manner. The last comes the design reviews. In design reviews, the critical design review is taken care. Through this review, Design ensures all aspects meet the required standards and are ready for production. This includes verification of design maturity, integration, and readiness for manufacturing. So this was all it about the design.
A very good evening to one and all watching this video. I am Shivansh Singh and I'll be taking you through the phase 5 and phase 6 of the aircraft system design. So, beginning with the manufacturing assembly phase, this phase is where our design concepts become a reality through precise construction and assembly processes. So it's a critical step that helps transform our detailed plans that we have already made into a tangible product, which is ready for the further stages of testing and validation. So this phase is further divided into further stages, such as the component manufacturing stage. So we'll begin with component manufacturing. So this stage begins with the selection and procurement of high quality materials, for example, aluminum alloys, titanium, etc., which are chosen for their specific properties, such as their strength or their weight or their durability, flexibility, etc. So these materials are crucial for different parts of the aircraft, ensuring that it can handle various stresses and future environmental conditions. So once these materials are selected, then comes our component fabrication. So once the materials are selected, they undergo various fabrication processes. These include processes such as casting, forging, machining, and processes like 3D printing. So each method is basically chosen based on the component's requirements and their performance criteria. So, for example, components which require high precision, they are machined, whereas components with complex geometry, they are made through 3D printing. So after our component selection is done, then we move on to subassembly. So this involves the joining of the different parts to create larger sections of the aircraft. So joining techniques like riveting, welding, and bonding are used depending on the material and the required strength of the joints, basically. So during sub-assembly, major sections such as the wings and the tail assemblies are constructed. And this modular approach is essential as it allows for easier handling and transportation of the parts and streamlines the final assembly process. So by creating these modules, we can ensure each section meets the strict quality standards before being integrated into a larger structure. So after the sub-assembly, then comes our final assembly. So in the final assembly stage, these major sub-assemblies that we have created come together on the assembly line. And this is a very highly coordinated effort where precision and accuracy are very important. So integration of systems such as avionics, hydraulics, and electrical systems, these things occur here. So for example, let's consider the integration of a propulsion system. So the engines are installed and connected to the aircraft's fuel, electrical, and control systems. So this requires a very high amount of attention to detail to ensure everything is aligned correctly and securely fastened. So similarly, the avionics systems are installed and tested to ensure that they communicate effectively with other systems and perform their functions correctly. Uh, Further, alignment and fastening are critical aspects of final assembly. So, proper alignment ensures that the aircraft's components fit together perfectly, which is essential for aerodynamics and structural integrity. So, and fastening techniques as well are used to secure all parts, ensuring that they remain in place under operational conditions and extreme stresses. So, after the manufacturing and assembly process phase, then comes our testing and validation phase. Uh, in this phase, it's ensured that the aircraft meets all the design specifications and performance criteria and regulatory standards. So it includes a series of rigorous tests and evaluations to validate the aircraft safety and reliability function and functionality. So, like the last phase, this phase is divided into further stages as well. So, first, let's discuss about ground testing. So, in ground testing, we start with structural testing, which includes both static and fatigue tests. So, static testing involves uh, subjecting the aircraft structure to loads and stretches beyond normal operation limits to ensure that it can withstand extreme conditions. For example, we apply forces to the wings and fuselage to simulate scenarios like severe turbulence or emergency maneuvers. Uh, After that, we move on to fatigue testing, which simulates the long-term effects of repeated stress over the aircraft's expected lifespan. By cycling the loads on the aircraft structure, we can predict how it will perform over the years of service and identify any potential weak points that might develop. Uh, After that, it we have system testing. So system testing is also conducted on the ground itself. So we verify the functionality of the avionics, the electrical system, ensuring that the communication systems, navigation instruments, and electrical power distribution works flawlessly. So similarly, we test the hydraulic systems and other systems to ensure that the proper operation of landing gear, flight controls, and other critical systems are in place. So uh, further, like for example, the propulsion systems undergo engine run-ups and tests to validate uh, performance, fuel efficiency, and emissions. So these tests are conducted in controlled environments where we can carefully monitor the engine behavior and performance characteristics. After that comes ground-based functional testing. So during these tests, the aircraft is tested at various speeds on the ground to evaluate braking, steering, and low-speed handling. So this step is crucial for ensuring that the aircraft can maneuver safely on the ground, particularly during takeoff and landing. So system integration testing is another key aspect which involves comprehensive checks on how well all systems, such as the avionics, the hydraulics, the propulsion systems, work together. So it's not enough for each system to work independently. They must operate seamlessly as an integrated system. After that, we have environmental testing. So environmental testing, it ensures that the aircraft can perform under extreme conditions. So temperature and altitude tests are uh, conducted in specialized chambers where the aircraft is exposed to extreme cold and heat and high altitudes. So these tests verify that all systems function correctly under these challenging conditions. Uh, in environmental testing, we have vibrational and acoustic testing as well, which assesses the impact of vibration and noise on the aircraft. So, for example, we simulate the vibrations experienced during flight to ensure that all components remain secure and functional. So, acoustic testing measures the noise levels inside and outside the aircraft to ensure that they are within the acceptable limits. After that, we have electromagnetic interference and compatibility testing to ensure that the aircraft's electronic systems do not interfere with each other with extreme, like with external systems. So this is a critical step for reliable operation of the avionics and communication systems, especially. After that, after environmental testing, we have flight testing. So flight testing is the next major step where flight tests are conducted by experienced test pilots to evaluate basic aircraft handling, stability, and control. So these flights focus on uh, at the assessing the aircraft's performance where we have uh, yeah, assessing the aircraft's performance at the different speeds and altitudes and configurations. So performance testing, it involves a series of uh, flights to evaluate the aircraft speed, range, fuel efficiency, climb rate, and other performance metrics. So this step is essential for confirming that the aircraft meets its design and specification goals. So operational testing further, uh, it simulates the typical flight operations, including takeoff, landing, and emergency procedures. So these tests they ensure that the aircraft can operate safely and efficiently under real-world conditions. So pilots practice various scenarios to ensure that the aircraft performs as expected in all situations. So after all these, we have certification testing. So certification testing that ensures regulatory compliance. So the aircraft is tested to meet all requirements set by the various authorities, such as the FAA or EASA. So this includes safety tests, environmental standards, noise regulations, comprehensive documentation of all tests and results, and they are submitted for certification approval. After that, we have validation. So in this, we validate the operational readiness. So this involves final checks and adjustments based on testing outcomes. Potential customers or operators may conduct their own tests, for example, to verify the aircraft meets their specific requirements and ensures the customer specifications or satisfaction. So yeah, so that's all from my side for phase 5 and phase 6 of the aircraft system design, and Utkarsh will be taking on from here.
Hi everyone, myself Bhaskar Patel from the Department of Civil Engineering. I'll be discussing about the topic of delivery and deployment under aircraft system design. So the objective of delivery and deployment is a transition from aircraft production to operational status. The key activities that are involved in delivery and deployment are flight readiness check, crew training, logistical arrangement for customer handover. I will be discussing about manufacturing finalization here. So manufacturing finalization is optimization and adjustments. Final tweaking of manufacturing process ensures efficiency and quality. Issue resolution, addressing any minor issue identified earlier to ensure smooth production. Production. So full-scale production, transition from prototype to mass production, including assembly line setup. Like in the image, you can see there is an assembly line setup. Then there is quality control, implementing measures to ensure each aircraft meets required specifications. Then there is a delivery to customer. So in the delivery to customer, first of all, it is a handover process, includes final inspections and documentation transfer, ensuring all components meet customer requirement, provides detailed documentation such as logbooks, manuals, and compliance certificates. Customization implements customer-specific modifications, includes interior configurations and avionic setups to tailor the aircraft to customers' operation and needs. Initial operational testing and evaluation. Also in the short form, it is IoT and E. So it includes real-world testing and operational requirements. Real-world testing is like validates aircraft performance in real-world condition through initial flights test to ensure expected performance and identify needed adjustments. Uh, Operational requirements ensure the aircraft meets all operational requirements and compatibility with the customer's fleet and protocol. Then there is customer training. So in the customer training, as you can see, there are various simulators and the pilot training is there. So comprehensive training program is there, provides training for pilots, maintenance crews, personnel, include classroom simulators and hands-on session covering all operational aspects. Skill development equips personnel with necessary skills and knowledge, offering ongoing training and specialized programs for various roles. Support and maintenance setup. So, establishing a support network sets up maintenance facilities and spares part distribution, creating a global network of service centers and ensuring availability of parts. Technical support. The technical support offers 24 by 7 technical support and troubleshooting along with regular updates and service bulletins to maintain optimal aircraft conditions. So, in the conclusion, we can say that various topics have been covered in the 7 phases, uh, like, for example, the integrated process phased approach is there. So, the aircraft system design process integrates multiple engineering disciplines to create safe, efficient, and reliable aircraft. This comprehensive process includes requirements analysis, conceptual design, preliminary design, detailed design, testing, validation, and delivery and deployment, the last phase. Each phase ensures the final product meets the operational, regulatory, and customer needs. Requirements analysis defines clear needs, while conceptual and primary designs generate and refine ideas. Detailed design translates into plans ready for manufacturing and testing. Testing and validation performs the compliance and safety standard. So these are the various parts that are included in the phase-wise of aircraft manufacturing system. In the end, it is that the success in aircraft design relies on collaborative approach rather than one person doing, like in the assembly line, various people do the job. So it is a collaborative effort, integrating feedback and optimization that designed to meet the aviation industry demands. Thank you.